So hi everyone, welcome back to another video on the channel. In this video, we are going to solve another problem in our DSA series, that is how to rotate a number. So without wasting any time, let's dive into the problem and understand what is the objective of our problem and what approaches we need to apply to solve this problem. So to rotate a number means to basically shift the digits of a number such that the number appears rotated. And there are different direction of rotating a number such as positive rotation and negative rotation. Basically, we consider the clockwise direction of rotation as positive rotation and anti-clockwise rotation as negative rotation. Getting my point? So let's move into this demonstration of how rotation works to understand the things better. So let's say we have a number 27391. So what do you mean by rotating the number by 1? It means nothing but positive rotation. And as I already said, positive rotation means clockwise rotation. What do you mean by clockwise rotation? That means one number from the back will come to the front. Getting my point? So rotating by one, the number becomes 12739. Basically, this one at the back comes to the front. Similarly, rotate by two means two number will come from the back and come to the front. Here 91 is at the end, so we bring 91 from the back to the front. Similarly, rotating by 3, that means 127 or sorry, 391 over here is at the back. So we bring 391 from back to the front. So the number becomes 39127. So the remaining digits remain as it is in the back. So rotating by 4 means 7391 will come forward and 2 will remain at last. And notice one thing, if we rotate the number by 5, we get the same number back. Getting my point? If we rotate the number by its total number of digits, so we rotate it by 5, we get the original number back because if we take the whole 5 digits of the number, so basically that's the whole number itself, and then try to put it in the front, so we'll obviously get the same number back. Isn't that correct? Try to understand. We in every rotation we take a part of the number from the back and bring it to the front, but here we have all the digits of the number available to shift from the back and put it in the top or in the front. But that doesn't make any difference, right? Because if we take all 5 digits of the number, then the whole number is gone, then we again keep the number at same place. That means no change has been performed. So remember one thing, if we try to rotate a number by its total number of digits or any multiple of its total number of digits, such as here the total number of digits is 5, or the multiples of 5, such as 10, 15, 20, 30, 50, 500, or even 0, that means the number will not change at all. That is called zeroth rotation because that does not affect our rotation process. So in any problem, if we get that we are given to rotate the number by 0 or rotate the number by 5 place, rotate the number by 10 place, in case of a 5 digit number, that means that we don't have to perform any kind of rotation at all. We have to just return the number as it is. Getting my point? And similarly, if we rotate the number by 6, that is one more than number of digits present in the number, then we get which rotation? It is same as the rotate by 1 rotation. So if we exceed the number of digits of the number in the rotation, if we exceed the number of digits, then it is same as the remainder of the number of digits and the number that we are trying to rotate with. Getting my points? What I'm trying to say is that the fifth rotation is same as the zeroth rotation. The sixth rotation is same as one rotation. Seventh rotation will be same as second rotation. Why this is happening? Because the number of digits present in the number is 5. So if we try to rotate the number by 6, we get nothing but 6 modulo 5 rotation. That is 1. So rotate by 1 is same as rotate by 6 because 6 modulo 5 is nothing but 1. Getting my point? Similarly, we can rotate the number in negative direction as well. What do you mean by negative rotation? That means take the number from the front and put it in the back. That is nothing but our anti-clockwise direction of rotation. So here, rotating by -1 means we have to take the 2 from the front and put it in the back. Similarly, rotate by -2 means take the 2 7 at the top or at the front, put it in the back. Similarly, rotate by -3 means take 3 digits from the front and put it in the back. So as simple as that. And also the minus fifth rotation is same as the number itself, because as we know, if our rotation is same as the number of digits, then we get the same number back. And the number of rotation exceeding the number of digits, we will have to modulo the exact number with the number of digits, such as sixth rotation is same as the first rotation, because sixth rotation is nothing but 6 modulo 5. We have to rotate 5 times, which is basically nothing but 0 times. Then we have to rotate one more time. That means that we have to rotate just one times. Instead of 6 times, we have to rotate just one times. Getting my point? Here is the diagram, which will help you understand the things better. When we rotate by plus 1, it is same as when we rotate by minus 4. Let's see over here. When we rotate by plus 1, it is same as when we rotate by minus 4. When we rotate by plus 2, it is same as when we rotate by minus 3. Let's see if it's correct. When we rotate by 2, we get 91273. When we rotate by minus 3, we get 91273. So you can check the remaining rotation as well. You will get the same thing. Plus 3 rotation is same as minus 2. Plus 4 rotation is same as minus 1. Plus 5 rotation is same as minus 5. So what is the logic behind it? There is some kind of relation between the positive rotations and negative rotation. If we crack that logic or relation, we don't have to write too much length of code. We can adjust everything and all the cases like positive rotation, negative rotation, rotation values greater than the number of digits of a number. All these cases are sub cases of this problem. So if we try to solve each sub case one by one, then we can integrate them into our problem and find the exact solution. So what is the relation between plus 1 and minus 4? So plus 1 is nothing but the number of digits 5 plus minus 4. So my minus 4 rotation is same as plus 1 rotation. Minus 3 rotation is same as plus 2 rotation. Minus 2 rotation is same as plus 3 rotation. And how can we get that? We can get that by adding the negative rotation by the number of digits. As we know, minus fourth rotation is same as plus 1 rotation. So instead of doing minus 4 rotation, we can just do plus 1 rotation. And how can we get the fact that minus 4 rotation is same as plus 1 rotation? We just have to add the negative rotation by the number of digits. So 5 plus minus 4 is nothing but 1. So we get 1 rotation. So minus 4 rotation is same as 1 rotation. So question may be given that 2 minus 4 rotation, but we have to do plus 1 rotation because we don't have to write logic for negative rotation and positive rotation. We have to integrate all the things in the same method. We will write the logic for plus rotation or positive rotation, and in that method we will try to integrate the logic for negative rotation as well, because negative rotation can be represented in form of positive rotation. So here we see how negative rotations are being represented in form of positive rotation. So here we are given minus 4 rotation. Minus 4 rotation is same as plus 1 rotation. How can we get plus 1 rotation? By adding the minus 4 value with the number of digits. So we get plus 1. Similarly, for minus 3, we add with number of digits, that is 5. We get 2. 5 plus minus 3 is equal to 2. So we have to rotate the number by 2 instead of minus 3. So this is the formula. 5 plus n is equal to n. So sorry, this is the thing that I was trying to say you earlier, that when we try to rotate the digits by any number greater than its number of digits, so we get the k percentile 5 or k modulo 5. 5 why? Because the number of digits over here was 5, but in normalization case or for any given problem, for any value of rotation by k, we have to get the modulo of the number, because the question may ask that rotate the number by 500 times. So will you do the given operation 500 times? That will add up many more complexity and the program has to run for many number of time. That is not optimal, right? The main purpose of the DSA is to save the time and space resources of the computational resources. We have to save time and space. So how can we achieve that? Instead of 500 rotation, we know that 500 rotation is same as 0 rotation, because the number of digits is 5 and 500 is the multiple of 5. So instead of 500, we have to rotate the number by 500 modulo 5. We get 0. So we have to rotate the number by 0. So this saves our time complexity of the problem. So n is nothing but the number of digits of the problem and k is nothing but the number of rotation that we have to perform. Similarly, we have seen in this case over here that if k is negative, that number of rotation is negative, then how can we get the positive value? The positive counterpart value, we can add the number of digits with the negative rotation value. Here, rotate by minus 4 is equal to number of digits, that is 5 plus k. K is nothing but our rotation value. Here, rotation value is minus 4. So we get number of digits plus k. So what value we get by this? We get minus 4 plus 5. So that is rotation by 1. So these two are the sub cases of our problem, that we may have been given a very very large rotation value. So instead of performing such large number of rotation, we have to optimize this by k modulo n, or performing the modulo operation, because the rotation are cyclic in nature. After every n rotation, where n is the number of digits of the number, the rotation values gets repeated in a cyclic manner. So that's why we have to perform the modulo operation. Similarly, for negative rotation, we have already seen the formula and how it works. So without wasting any time, let's go into our algorithm. So let's say we have been given a number 27391. This is our number. So let's say we have to rotate it by two digits. So what does that mean? Here we have been given positive rotation, that means clockwise direction. That means take two digits from the back and put it in the front. What does that mean? We have to take this 91 out and put it in the front. Now, how can we achieve that programmatically? We are saying verbally that put that 91 from the back to the front. How can we achieve that programmatically? Getting my point? So, first of all, we have to find the number of digits n. Here we have to find the number of digits n of the given number, that is 5. Then we have to multiply this 91 with some multiplier, and then divide this 273 with some divisor, so that 91 place value become higher than 273, because 91 coming forward means that this 9 and 1 are getting an increment in their place value. In the original number, the value of 9 and 1 are tens place and ones place. In the rotated number, the value of 91 is increased because their place value are now higher than that they were in the original number. Similarly, this 273 was in the front in the original number. That means their place value was higher. In the rotated number, they are being pushed back. That means their place value is getting reduced. So to increase and reduce the place value of these both parts, we need to multiply it with some multiplier and divide it with some divisor. Then our task is to find this multiplier and divisor. So the divisor is nothing but the 10 to the power k. The rotation value is our divisor. We have to divide the number that we need to push back by the rotation value. Here we have to push this 273 back. That means we have to divide this 273 by 10 to the power 2, because our rotation value in the given problem is 2. So we have to divide this 273 with the 27391 with the divisor. Getting my point? Check this out. You will understand the problem much better. So we have to rotate the number by 2. That means we have to extract two number from the back and put it in the front. Two numbers in the back, we can easily get it by applying some logic of getting the digits from the back that we are already aware of. We will see that in the code. But how can we achieve that front three digits that we have to send to the back? We can do it by dividing the number with a divisor. So our divisor is nothing but the 10 to the power k. K is nothing but our number of rotation. So the number of rotation is 2. So when we divide the number to whole number given by 10 to the power 2, we get 273, which is nothing but our number that is to be sent back. Getting my point? Similarly, we have to multiply this 91 with a multiplier so that its value gets increased and it becomes a increased number. Because if we try to move this 91 to the front, that means our number is going to increase from 27391 to 91273. It's going to increase. So what is our multiplier? Our multiplier is nothing but 10 to the power n minus k, number of digits minus number of rotation. So the number of multiplier value becomes 10 to the power 3. So we have to divide the number by divisor to get the number that is to be pushed back, and then we have to multiply the value with the remainder, because when we get the quotient of this number 27391, when we get the quotient of this number, what we get? We get 273. When we do 27391 by 10 to the power 2, what is the quotient that we get? We get 273, because 27391 by 100 will give us 273 point something. That means our quotient becomes 273. So what is our remainder? Our remainder is nothing but 91. 91 is our remainder. So we know now how to get the both parts of the number that is to be sent back and the number that is to be sent in front. So we will get that by dividing the number with the divisor. The quotient is the number that is to be sent back, and the remainder is the number that is to be sent in front. So to send a number in front, we have to multiply something. So we got that value by multiplier. So we have to multiply the remainder with the multiplier value that we have got from here. And then we have to simply add the quotient value. The quotient value is nothing but the number divided by the divisor. So here we get our required number. Let me dry run this case to you so that you can understand it better. We have been given 27391. We have to rotate by two places. So our number that we are trying to get will be this one, 91273. Okay. So first step, find the number of digits, that is 5. Second step, extract the divisor, that is 10 to the power k, that is 10 to the power 2. Multiplier, you have to extract, that is 10 to the power n minus k, that is 10 to the power 3. Divide the number by divisor, that is 27391 by 10 to the power 2. We get 273. Then multiply the multiplier with the remainder of this number, n by divisor. We get quotient as 273. What is the remainder? 91, of course. We have to multiply the remainder with the multiplier, then add it up with the quotient. So what is 91 into 1000 plus 273? That is 91273. Getting my point? So that is our logic to rotate a number. So I think it's extremely clear for everyone what is our logic. So in simple manner, we have to extract the number of digits. Then we have to find the divisor, which is nothing but 10 to the power k, and we have to find the multiplier, which is nothing but 10 to the power 9, 10 to the power n minus k. Then we have to divide the number by divisor and extract the quotient and remainder. The quotient is the number that is to be sent back, and the remainder is the number that is to be sent front. As the remainder is to be sent in front, that's why we have to multiply the remainder with some multiplier so that it becomes larger in terms of place value. So that is our extremely simple logic to rotate a number. So this is the programmatical way to how to do this problem. So first of all, we have to extract the digits by using this formula. We have already discussed this approach in the previous video where we have a section how to extract the digits of a number. If you haven't watched that video, you can definitely watch that out. If you are confused in the first step of the code, I have explained this in the details. So we are using the log method, which is present in the math class, to extract the digits of the number. So after extracting the digits, we have to apply these two checks. For the higher value of the rotation, we have to modulo the value by the digits. We have to reduce it so that we have to perform less number of rotation. As we know, rotation is cyclic in manner. So we can apply the modulo operation to reduce the value of our rotation. Similarly, if we have been given a negative number, we have to add the number of digits so that we can represent the negative rotation in terms of positive rotation. Similarly, we have to find the divisor, we have to find the multiplier, then we have to find the rotated number. So now let's move into the code editor and solve the problem. So this is our problem statement, and we have to rotate the number and return it. So let me, first step, we have to apply checks. Sorry, in the first step, we have to extract the digits of a number. So what is the step one? Step one is extract the digits of the number. Int digits will be nothing but int math.log of 10 and this one. So our given number is num. So instead of 10, we write num. So this will extract the number of digits in our problem. So n is our number of rotation. In the step 2, apply the checks that we have learned how to handle the negative rotation and higher value of rotation. For the higher value of rotation, we have to modulo the n value by number of digits. And for negative rotation, if n less than 0, we have to add the number of digits to the n so that we can get the positive counterpart of it. Now apply the logic. First of all, we have to get the multiplier and divisor. Get the multiplier and the divisor. So int divisor is nothing but math.power. So our divisor is nothing but 10 to the power number of rotation, which we had 10 to the power k over here. So as the math.power function will return a double value, we have to typecast it with int. Similarly, int multiplier will be We have to typecast it with integer value, and then we have to take 10 to the power n minus number of digits. Sorry, number of digits minus n, because number of rotation, as we have already did the applied the checks, so our number of rotation will be always less than the digits. So we have to calculate the 10 to the power n minus k. K is nothing but our number of rotation, and n is our nothing but the number of digits. So int rotated number is nothing but we have to multiply the check over here. Which number was multiplied? This one, 27391 by 10 to the power 2. Which number was multiplied? 91. 91 is nothing but the remainder of the division. Which division? Num by divisor. So here, instead of quotient, we need the remainder of the division, because the remainder will be multiplied with the multiplier. Similarly, then add it with the quotient, that is num by divisor. Also, we have to typecast the value with integer so that no double value conflict will arise. I think there is a whole bracket in front of it, so I don't need to add another bracket. Then instead of this -1, we have to rotated num. Return this rotated num. Now let me compile this problem and get the output. Enter a number. Let me give that same number 27391. 27391. Rotate by. Let me give the same rotation value, that is 2. The number 27391 after being rotated 2 places becomes 9373. So what is our problem? So let me check what is the problem. That's why we are getting this inconsistency. So I think we don't need this int over here. Let me run this again. 27391 rotated by 2. So I think there is a problem with the logic. First of all, we have to extract the digits that we already did by, okay. So I have, okay, this +1 will be added here. So now our code will work properly, because when we get the logarithmic value of a number, we get a number that is one less than the number of digits of a number. So with this function, we have to add a 1. So instead of inside that function, we have to add that 1 over here. 27391. Sorry, I have to write the thing over here. 27391. Let me drag it over here so you can see it. Rotate it by 2. As you can see, 27391 becomes 91273 after rotated. So we have to compile it again and check it again. Let me give the same number. Rotate by 2 places rotation is same as -3 rotation. So let me give a negative value. -3. So we get the same number back. Let me compile again, and let me this time 27391, and let me give a number that is 5, which is nothing but the number of digits. So we get the same number back. Let me give a big number like 27391 and rotate it by 500. As 500 is the divisible or the divisor of or the multiple of the number of digits n, so we get the same number back. Let me run again. Let me give the same number and let me give a value that is 6. So 6, 7. Seventh rotation is same as second rotation. So the second rotation is also 91273 that we have already seen over here. So let me run again and 27391. Let me give a big number. So as you can see, even for this big number, our program output is getting compiled and we are getting the output in the fraction of seconds. So I think the logic is clear to all of you. If you have any doubts, you can definitely reach me out in the comments. I will be happy to answer your doubts. If you need these notes or anything that I have showed in the previous video, if you need this kind of notes, you can definitely ask me in the comments. I will send you the PDFs of these notes so you can use this for future reference. So that's it for this video. Until we meet next time, keep learning.